At 14:23 hours on August 7th, 1944, Flight Lieutenant Johnny Baldwin rolled his Hawker Typhoon into a 60-degree dive toward a German Panther tank on the road near Mortain. Altitude 8,000 feet. Airspeed building through 300 knots. The target was moving east at approximately 20 kilometers per hour. Baldwin fired his 4 20mm Hispano cannons to judge range. Tracers walked across the road ahead of the tank. He corrected. At 4,000 feet and 1,555 meters slant range, he pressed the rocket firing button. 8 RP-3 rockets launched simultaneously from rails under his wings. Each rocket weighed 60 pounds. Each carried a 27-kilogram high-explosive warhead. The firepower of one Typhoon salvo equaled a destroyer's broadside. The rockets whooshed off the rails trailing white smoke. They diverged. Wind, gravity, slight variations in rocket motor performance, and the stress of 7G pullout created dispersion. The rockets impacted across a 50-meter circle. None hit the tank directly. 2 exploded within 10 meters. The blast wave and shrapnel damaged the tank's tracks and external equipment. The tank stopped. The crew bailed out. Baldwin climbed away at full throttle. Ground fire followed him but did not hit. Total attack time was 12 seconds. Baldwin reported 1 tank destroyed. The intelligence officer recorded it by the end of the day. Typhoon pilots from 2nd Tactical Air Force claimed 252 tanks destroyed at Mortain. Post-battle analysis by Operational Research, Section 2. Investigators found 10 German armored fighting vehicles destroyed by rocket fire. The remainder were destroyed by American ground forces or abandoned by crews fleeing air attack. The actual kill rate was 4% of claims, but the psychological impact was total. German tank crews heard Typhoons approaching and abandoned vehicles that were undamaged. The Typhoon did not destroy German armor through accurate gunnery. It destroyed German armor through terror. The story begins in 1937, when Sidney Cam, chief designer at Hawker Aircraft, began work on a Hurricane replacement. The Air Ministry wanted a fighter capable of defeating the next generation of German fighters. The specification required maximum speed exceeding 400 miles per hour, heavy armament, and high-altitude performance. Cam proposed 2 designs. The Tornado would use the Rolls-Royce Vulture engine. The Typhoon would use the Napier Sabre engine. Both engines were liquid-cooled 24-cylinder designs, generating over 2,000 horsepower. Both were experimental. Both had development problems. The Typhoon prototype flew on February 24, 1940, at Langley with test pilot Philip Lucas at the controls. The aircraft was large. Wingspan was 12.67 meters. Length was 9.73 meters. Empty weight was 3,992 kilograms. Maximum takeoff weight was 6,010 kilograms. The Napier Sabre Tie-Dye A engine generated 2,180 horsepower. Maximum speed was 679 kilometers per hour at 3,800 meters altitude. This exceeded the specification requirement. Initial armament was 12 7.7mm machine guns. This was later changed to 4 20mm Hispano cannons. The cannon armament made the Typhoon one of the most heavily armed fighters in the Royal Air Force. The Typhoon entered service in September 1941 with No. 56 Squadron. Problems emerged immediately. The Sabre engine was unreliable. Cylinder heads cracked. Sleeve valves stuck. Oil leaks were chronic. Engine failures occurred frequently. Several pilots died when engines failed during takeoff or low-altitude flight. The fuselage tail joint was structurally weak. Several aircraft broke up in flight when the tail separated during high-speed maneuvers. Modifications were required. Metal reinforcing plates were installed at the tail joint. Engine cooling was improved. Maintenance procedures were revised. But the fundamental problem remained. The Typhoon was designed as a high-altitude interceptor. It performed poorly at high altitude, above 6,000 meters. The Sabre engine lost power. The thick wing section that provided structural strength and weapon volume also created compressibility problems at high altitude. The aircraft buffeted and lost control effectiveness approaching its maximum speed. German Focke-Wulf 190 fighters operating at 7,000 meters altitude could outperform Typhoons. The Luftwaffe avoided combat below 5,000 meters where Typhoons had advantage. By early 1942, the Typhoon was failing in its intended role. The Air Ministry considered canceling production. Hawker argued for continued development. The aircraft had potential if employed differently. The breakthrough came in low-altitude operations. At altitudes below 3,000 meters, the Typhoon was fast and maneuverable. The thick wing provided excellent low-speed handling. The 4 cannons were devastating against ground targets. From mid-1942, Typhoons were assigned to low-altitude interception of Focke-Wulf 190 fighter bombers conducting hit-and-run raids on coastal targets. The Typhoons caught the raiders and shot them down. Success in this role justified continued production. But ground attack would become the Typhoon's primary mission. Bomb racks were fitted in late 1942. The aircraft could carry two 500-pound bombs or two 1,000-pound bombs under the wings. Typhoons flew armed reconnaissance missions over occupied Europe, attacking trains, vehicles, and troop concentrations. The press called them bombfoons. From late 1943, RP-3 rocket rails were added. 8 rockets could be carried, 4 under each wing. The rockets were 3-inch diameter solid fuel motors with interchangeable warheads. The 60-pound semi-armor-piercing warhead was standard for anti-tank operations. The 25-pound armor-piercing warhead had proven ineffective against Tiger tanks in North Africa. The 60-pound warhead contained enough explosive to damage or destroy any armored vehicle if it hit directly or exploded nearby. The RP-3 was inaccurate. Post-war analysis determined that Typhoon pilots achieved 4% hit rates against tanks under combat conditions. Accuracy was affected by multiple factors: release altitude, dive angle, airspeed, wind, target motion, G-forces during pullout, rocket manufacturing variations. The gun sight was designed for air-to-air gunnery and only slightly modified for ground attack. Pilots learned to use their cannons as ranging weapons. Fire the cannons first. Observe where the shells hit. Correct. Release rockets. Pull out. This technique improved accuracy, but never exceeded 10% hit rates against stationary vehicles under ideal conditions. But accuracy was secondary to effect. The psychological impact of rocket attack was devastating. German soldiers described the sound as terrifying. The rockets made a distinctive whooshing roar. 8 rockets fired simultaneously created noise audible for kilometers. The explosions were spectacular. A 60-pound warhead created a blast radius exceeding 20 meters. Shrapnel traveled over 100 meters. Vehicles hit directly were destroyed. Vehicles near misses were damaged. Crews exposed on or near vehicles were killed or wounded. Most importantly, crews hearing Typhoons approaching abandoned vehicles before attack. Analysis after Normandy showed that more German vehicles were abandoned intact than destroyed by fire. Operation Goodwood on July 18 through 21, 1944, demonstrated both the effectiveness and limitations of Typhoon operations. 2nd Tactical Air Force claimed 257 tanks destroyed. Typhoon pilots claimed 222. Post-battle analysis found 10 armored vehicles destroyed by rockets out of 456 knocked-out vehicles examined. The discrepancy reflected overclaiming common to all air forces. Pilots attacking through anti-aircraft fire and smoke could not observe results accurately. Multiple pilots attacked the same targets. Claims were duplicated, but the operation succeeded. German armor withdrew. British forces advanced. Whether Typhoons destroyed tanks physically or psychologically was strategically irrelevant. The result was the same. The Falaise Pocket in August 1944 became the Typhoon's most famous action. German 7th Army attempted to escape encirclement. The roads were packed with vehicles. Typhoons attacked continuously. Pilots described targets everywhere: tanks, trucks, artillery, ambulances, staff cars, everything trying to escape through a narrow corridor. The attacks created chaos. Vehicles collided. Traffic jammed. German forces abandoned equipment and fled on foot. Estimates suggested 15,000 to 20,000 vehicles were destroyed or abandoned. Typhoon pilots claimed over 1,000 tanks destroyed. Actual tank losses were approximately 300, but the 7th Army was annihilated. The equipment left behind exceeded anything captured previously. 26 Typhoon squadrons operated during the Battle of Normandy. Each squadron typically fielded 12 aircraft. Total strength exceeded 300 Typhoons. They flew from bases in southern England initially, then from forward airfields in France once sufficient strips were operational. The forward deployment reduced transit time and increased sortie rates. Pilots flew 4 to 6 missions daily during peak operations. Maintenance crews worked continuously to keep aircraft operational. Armorers assembled rockets in dusty fields. Ground crews repaired battle damage using improvised techniques and salvaged parts. The casualties were severe. 151 Typhoon pilots were killed in action during Normandy operations. This represented 22% of pilots who participated in the campaign. The loss rate exceeded that of most other Royal Air Force units. Typhoons operated at low altitude where they were vulnerable to ground fire. German anti-aircraft weapons included 88mm guns, 37mm guns, and 20mm cannons. The density of anti-aircraft fire over Normandy exceeded anything previously encountered. Pilots described it as walking on flak. The sky was black with explosions. Avoiding fire was impossible. Surviving required luck as much as skill. The Luftwaffe targeted Typhoon bases. German fighters attacked airfields as Typhoons returned low on fuel and ammunition. On January 1st, 1945, during Operation Bodenplatte, Luftwaffe fighters attacked the airfield at Eindhoven. 26 Typhoons were destroyed on the ground. 30 more were damaged. The attack temporarily disabled the base. Similar attacks occurred throughout the campaign. The Luftwaffe prioritized Typhoon squadrons because their ground attack capability was devastating German operations. A directive issued by German command stated that captured Typhoon pilots should be executed immediately. This violated Geneva Convention requirements, but reflected German desperation to stop Typhoon operations. The technical evolution continued through 1944 and 1945. The original car door-style cockpit canopy was replaced with a bubble canopy, providing better visibility. Air filters were installed to protect engines from dust ingestion on forward airfields. Radio equipment was upgraded to improve coordination with ground forces. Some aircraft were fitted with additional rocket rails, allowing 12 rockets instead of 8. The modifications were field expedients rather than factory installations. Squadron engineers improvised solutions to operational problems using available materials. Post-war assessment required, separating legend from reality. The legend was that Typhoons destroyed German armor through accurate rocket fire. The reality was that Typhoons disrupted German operations through continuous attacks that made movement impossible. The actual physical destruction was limited. The 4% hit rate meant that 96% of rockets missed their targets, but the missed rockets still exploded. The noise and blast created an environment where German forces could not operate effectively. Tank crews abandoned vehicles. Convoys dispersed. Commanders lost control. This disruption was the Typhoon's true contribution. The comparison to American fighter bombers reveals different approaches. The Republic P-47. Thunderbolt carried similar ordnance, but emphasized bombs over rockets. American doctrine preferred bombs because they were more accurate and easier to aim. British doctrine preferred rockets because they allowed standoff attack. Rockets could be fired from 1,500 meters. Bombs required overflying the target. Both approaches achieved similar results. German forces were equally disrupted by American and British attacks. The weapons were less important than the continuous presence of fighter bombers, preventing German movement. The strategic impact was enabling Allied ground advances. Normandy terrain favored defense. Hedgerows provided cover. Villages were strong points. Roads were killing zones. German forces should have been able to delay Allied advances significantly. But they could not concentrate forces because Typhoons attacked any visible concentration. They could not resupply because Typhoons attacked supply columns. They could not maneuver because Typhoons attacked moving formations. The ground war proceeded faster than planned because air power prevented German defensive operations from functioning effectively. This capability came at cost. The Typhoon was a specialized weapon requiring continuous support. Each aircraft required approximately 50 man-hours of maintenance per flight hour. Engines required replacement after approximately 100 hours. Rockets required assembly and loading before each mission. Forward airfields lacked facilities. Everything operated under improvised conditions. The logistics burden was substantial, but the operational effect justified the cost. German commanders reported that Typhoon attacks made daylight movement impossible and restricted night movement severely. The aircraft itself was never fully satisfactory. The Napier Sabre engine remained problematic throughout its service life. Oil consumption was excessive. Cooling system failures were frequent. Maintenance intensity exceeded comparable aircraft. The thick wing created handling issues at high speeds. The structural reinforcements added weight and reduced performance. Pilots described the Typhoon as a handful to fly. It was fast and powerful but required constant attention. Engine instruments had to be monitored continuously. Throttle movements had to be smooth. Rough handling caused mechanical failures. But pilots respected the aircraft. It was tough. It absorbed battle damage and continued flying. The thick wing and robust structure protected pilots. Multiple accounts describe Typhoons returning with major damage. One aircraft returned with over 100 bullet holes. Another returned with half the rudder shot away. The aircraft brought pilots home when lighter fighters would have failed. This reliability created confidence. Pilots flew aggressively because they believed the aircraft would survive. The Typhoon was replaced by the Hawker Tempest in late 1944. The Tempest was a refined Typhoon with thinner wings and improved engine. It was faster and more maneuverable. But Typhoons continued operations through the war's end because production was established and squadrons were trained. The last Typhoon combat mission occurred on May 9th, 1945. The squadron attacked German vehicles attempting to escape into Czechoslovakia. No German fire was encountered. The war in Europe had ended. Total Typhoon production reached 3,317 aircraft. Most were built by Gloucester Aircraft Company. Hawker focused on other designs. The aircraft served from September 1941 to May 1945. It evolved from a failed interceptor to a successful ground attack aircraft to a legendary tank buster. The legend exceeded the reality. Actual tank kills were minimal. Psychological impact was total. This is the paradox. The Typhoon became famous for something it rarely accomplished. It destroyed few tanks directly, but it destroyed German armored operations completely. The Normandy Memorial in Noyers-Bocage was dedicated on June 9, 1994. Major Roland Houdier, who witnessed Typhoon attacks in 1944, organized the dedication. Former squadron leaders attended. Typhoon pilots in their 70s described missions flown 50 years earlier. They remembered the terror and exhilaration. They remembered comrades who died. They remembered aircraft that did not return. They understood that their success was measured in disruption rather than destruction. They did not destroy every tank they attacked, but they prevented every tank from accomplishing its mission. That was enough. This is the Hawker Typhoon, designed as an interceptor, failed at interception, repurposed as ground attack, became legendary as tank buster, actually killed few tanks, actually disrupted all tanks. 3,317 built, 151 pilots killed at Normandy alone, 4% hit rate, 100% psychological effect, 8 RP-3 rockets, 60-pound warheads, firepower equivalent to destroyer broadside, accuracy equivalent to area bombardment. The weapon that was inaccurate but effective, the aircraft that succeeded by failing differently than expected, the tank buster that rarely destroyed tanks but destroyed tank operations. That was the Typhoon. Terror on rails, the sound that made German crews abandon undamaged vehicles, the legend built on disruption rather than destruction, the failed interceptor that became the most feared ground attack aircraft of the European theater.